In the name of Allah, the Compassionate and the Merciful. Hello guys, my name is Salar Delavar Qashqai. In this video, we're going to model the soil structure interactions with very simple model as a spring concepts as a soil modeling. You see guys in here, in first example, we have a column with 6 degrees of freedom, and we're going to model the soil with lateral as a kx and ky, and also rotational spring as a kz for modeling of the soil stiffness, and also damping ratios. If you like it, you can indicate it in your model, and then defining the initial displacement and also lateral pressure as a harmonic loading, and then run it the dynamic analysis in OpenSees. You see guys, and in second example, all the parameters is the same, but in the foundations also we add the mass and then run it again and seeing the difference results properties. So you see guys in here, if we run it, the result of displacement, velocity, accelerations, and also horizontal spring force as this shape, and also you see guys velocity, moment at the path of the column, and also element force, base shear is going to be shown, and also you see base reaction and displacement has a linear relations based on these defined materials and mass and stiffness of the structures. So in the second analysis, you see we defined mass at the foundations, and then applying the initial displacement and run the free vibration analysis, and after free vibration analysis we are going to apply the harmonic loading, and then you see in here we're going to plot the displacement, velocity, accelerations, and horizontal axial spring force, and also vertical axial spring force for modeling of these spring forces in a vertical and horizontal direction, and also moment of the soil, and also element force as a base shear of this at the beginning of the column, I mean these positions. You see guys in here, and so let's see the OpenSees file. In OpenSees file you see for different soil you can define different stiffness properties. Also damping ratios for different soil is going to be shown in here, and also this report is awesome. I recommend you guys to read it to better understanding of the soil structure interactions. And you see in first example we defined many functions for plotting, and also running the analysis with Newton-Raphson or other algorithm methods. And you see in here we define the columns properties as a section width and height, and also length of the column, and also calculating the lateral column effective stiffness, and also defining the initial displacement, damping ratios for the structures, and also defining the soil damping ratios if you want to indicate the soil damping and also mass of the soil. And for these two parameters is going to be used if you want to indicate the soil damping ratios. And also in here we defined two masses for our two examples, and mass in a foundation and mass in the top of the column. And let's see in here, the column strain and stress relations, and also defining the fiber sections properties, and also defining the harmonic loading times start from 2 until 12, and the period equals to 3.2 second, and then load factors equals to 15. You can change it with your own, and the code's available in my GitHub. You can download it and trying to change it with your own data. And also in here for better simulating the soil behavior, I defined 4 kind of spring material properties. The first one is elastic soil properties, and also elastic no tension soil properties with these coefficients, these guys in here. And also I defined the elastoplastic soil and with these properties as a spring coefficients, and also for horizontal, vertical and rotational spring, it's going to be shown in here. And also I defined the other material properties to better simulating the defined force displacement of each spring's behavior. And in here we are going to run the analysis as an interaction analysis. If we define the mass in one example, so if one mass is equals to true, so the first example is going to be run, and if it's false, so the second analysis is going to be run. So in here we're going to indicate the damping or true or false, soil damping true or false, and also defining the periods of the structures, and also indicating the structures, column structures behavior is linear or non-linear, and also defining the spring kind as a soil spring simulations, which I told you we can define 4 types of material properties for this kind of analysis. And then in here you see, guys, we are going to define the nodes, and then trying to define the boundary conditions and defining the mass. So if the mass is true, so we're going to just apply the one mass in the top of the column, and if the mass one is false, so the mass is going to be found in 2 points, like this, guys, like this. And let's see if the column behavior you defined it as a linear true, so the column properties sections has a linear relations as elastic material properties, and all if you defined it as a false, so the nonlinear behavior of the column as a material property is going to be defined. And also in here we define the these fiber sections for definition of the columns sections properties, and also defining the elements, and then outputting the displacement and base shear and also curvature of the column. And in here we are going to define the different soil structures, materials properties for different springs. And you see, if you defined spring kind equals to 1, so the elastic one is going to be defined, and then if you define these properties, so the inelastic materials properties for these springs is going to be defined for our model. And let's see in here. In here we are going to define the soil natural frequency, and you see this CS as a soil damping coefficient is going to be calculated, and also defining the elastic damping soil ratios for our model. And then in here we're going to define the soil damping if it is true, so we're going to define the soil damping and also stiffness for our model based on the materials properties which we defined it at the top of the sections in here, as you guys in here. And also we defined the initial displacement in here, and then run it. And if we define the in here, so we're going to calculate the period of the structures and also frequency, and if we turn it off as a false, so it's not going to be calculated, and then outputted the data. And in here we are going to applying the harmonic loading and running the dynamic analysis, and also trying to calculate the damping ratios if it's true or not, and then trying to run the analysis with the some steps which defined it during the analysis. So our duration is 50 seconds with the steps of 0.01 second. And let's see in here, you see guys, I defined the materials soil materials properties with these relations for our model as a fourth defined properties. I mean this behavior for modeling of the springs in lateral and rotational springs. See guys in here, and you see I indicated this behavior. And if we run it for undamped and damped conditions, so after 6 seconds we're going to plot it, and you see that it's going to be shown as a different time history of the results as a velocity, displacement, accelerations, and different spring forces, and also column element base shear, and also base reaction and displacement. You see the linear, it shows the linear relations. And also in second example, all the process is the same, but in here in the foundation we indicate the mass and then run it again. So you see guys, we defined spring number 2. So in here we defined spring number 2 and trying to run it, and also defining the mass 1 equals to false. So the second example is going to be run with these properties, and after 68 seconds the analysis outputted data is going to be shown in here. You see velocity, accelerations, and different spring force is going to be shown in here, and also base reaction and displacement has a linear relations. You see guys, each parameters of this analysis you can change it as a true or false for indicating the different properties and different result of this analysis. For example, if you in here we are going to define the damping ratio as a false and the second one is true. So if we indicate the damping of the structure, so we are going to output the damped period or damped displacement results. You see guys in here, and also we indicate the linear equals to false. So it means that we are going to define the nonlinear behavior of the material properties for our column modeling, and also indicate the spring current equals to 2. It means that we are going to define soil properties as inelastic behavior, and also we indicate the soil damping. So we are going to define in here stiffness and damping ratios for each of these columns for better simulating the soil and structures behavior. As I told you before, you can define different soils properties for definition of the stiffness and also damping ratios, and actually you can change it with your own, and this code's available in my GitHub. You can download it and change it with your own. So let's see the other example. The other analysis, we are going to define the same structures with 6 degrees of freedom and initial velocity, and also defining the vertical and horizontal seismic accelerations applied at the base of these structures, and then defining the same material properties for defining the soil as springs. And also you see we have just one mass in here, and in second analysis we have two mass. So the first one in the foundation and the second one in the top of the column. If we run the analysis, you see the displacement, velocity, accelerations, time history, and different spring forces going to be calculated. And you see guys in here we defined it the initial velocity. So the first initial velocity is going to be applied, and then seismic accelerations in vertical and horizontal direction is going to be applied during the 0 until 10 seconds, and then this behavior of the undamped and damped conditions is going to be shown with the calculated data. And also vertical axial spring, you see guys in here, moment spring forces, and also base shear forces, which is called element force. And you see the base reaction and displacement has a linear relations. So, and in here all the process is the same. We are going to apply the initial velocity, and also after that applying the seismic acceleration at the base with the horizontal and vertical directions with the defined time history, and then run it with two mass in foundation and in the top of the column. And then you see displacement, velocity, you see the initial velocity is going to be applied, and then run it with seismic accelerations dynamic analysis. And you see in here horizontal axial spring has time histories like this, and you see that damped and undamped conditions, and you see the vertical and axial spring forces reactions time history, and also moment, and also element force as a base shear at the bottom of the column, and also base reaction and displacement for this analysis. You see guys, in here we defined a very simple model of the soil structures interactions with springs, with indicating the soil's damping and stiffness ratios and different parameters which you can change it with your own to promote this model. So let's see the OpenSees code of this example with the initial velocity and two seismic acceleration in horizontal and vertical direction. All the parameters and functions is the same, and same properties, and material properties for spring stiffness and damping ratios, and also column properties is the same. But in here we are going to define the different time series for horizontal and vertical direction with the defined seismic accelerations file. And also you see in here we define the initial velocity and run it in horizontal and vertical directions, and run it the dynamic analysis. And you see guys, we're going to output the data with this true or false which I told you, and you can change it with your own, and run it for two kinds of one mass or two mass model. And also in here with two masses the analysis of structures for undamped and damped conditions. So in mass equals to false, and also other parameters is the same as before. And you see after 102 seconds the analysis is going to be stopped, and then showing the different time history results for displacement, velocity, accelerations, and different parameters which we want to be outputted the data. These videos which I prepared just for educational purpose, please have a comment and tell me no about this kind of modeling. Even you can email me and tell me about your opinion about this kind of modeling. God bless you guys. Bye.